Good morning. Today, my AAT subject is Object Oriented Software Engineering, and the topic is what are the various components in the sequence diagram. Interaction diagrams. The UML specifies a number of interaction diagrams to model dynamic aspects of the system. The dynamic aspects of the systems can be as messages moving among the objects or classes, flow of control among the objects, and sequences of the events. Dynamic diagram types. Interaction diagrams. The set of objects or roles and the messages that can be passed among them. Sequence diagrams emphasizes the time ordering. Communication diagrams emphasizes the structural ordering. State diagrams. State machine consists of states, transitions, events, and activities of an object. Activity and swim lane diagrams emphasize and show flow of the control among the objects. Sequence diagrams. It describes the flow of messages, events, actions between the objects. Show concurrent processes and activations. Show time sequences that are not easily depicted in other diagrams. Typically used during analysis and designed to document and understand the logical view of your system. Emphasis on time ordering. Here, the given example is a student. He wants to attend a seminar and the course. So, in the sequence diagram, a student first should enroll the student to the seminar, and then the student is eligible to take the course. The dotted black line indicates that the student enrolled for the seminar, and the next indicates the student eligible to take the course. And the next reverse black line indicates that the student can get the seminar history as well because he enrolled to the seminar and the course. The dotted line indicates the seminar history, eligibility status, and enrollment status. This depicts the sequence diagram's components. In this given slide, we can see all the lines should be horizontal to indicate instantaneous actions. Additionally, if activity A happens before activity B, activity A must be above the activity B. So this is the condition which we have to keep in mind when drawing the sequence diagrams. And the vertical line indicates the time incremental when depicting the sequence diagrams. Diagonal lines. If one wants to get details about the other, that is in this figure, it shows the student needs to get the details about registration system. Then the line indicated should be diagonal in the sequence diagram. So time A, the student takes to get details of time B. This is a diagonal representation for a sequence diagram to get the details of a student or the registration system. Components. Objects. A student is a specific instance of the student's class. So the student indicates the specific instance of an object. Here, the seminar and the course are the generic or unnamed objects of class type seminar and the course. Components. Here, the vertical rectangles indicates that the lifeline for the students on the student course, and at the right of the slide we can see another vertical rectangle. Here this shows the execution of the course. So from the lifeline to the execution, the horizontal lines depicts the enrollment, eligibility status, and the seminar history of the student getting the seminar and the course registrations. Here, from the left to right arrow mark indicates the method call, and from the right to left indicates the return value. Here we can see a student enrolled to a seminar is from left to right, that is enrolled student. So this is a method call. From the seminar to the course, we have another method call, that is student eligible. And from the course back to student, we have a get seminar history. And this is a return value, which indicate with the right to left arrow mark. Components. Here the first is a client that is creating a transaction, and from a set of actions that is a comma b comma c of transactions, and to obdc proxy that is values a 3 4. From the proxy back to transaction we have a return value, and from the transaction the indication should be mentioned with a reverse return value that is committed or not. And then the client will be accepting or destroying the transaction by giving a destroy application. So here we have components called create and destroy from client to transaction. And the straight arrow mark indicates synchronous message, whereas the thin arrow mark indicates asynchronous message, and the dotted arrow mark indicates the return message. So these are the official components of the sequence diagrams. Asynchronous message example. So till now we have take a look at the synchronous messages example. So now let us look into the asynchronous message example. So at the first we have a smart development environment with this actor. From the actor, uh, he or she should have to withdraw money from the ATM controller. So he have to first check the balance. So he can check the balance through a bank computer. From the ATM controller to the bank computer, he have to check balance, and the bank computer will be displaying the balance to the on the ATM controller, and then he have to decrement a balance amount. That is, he wants to withdraw the amount which he need to want. He can show it there. From the ATM controller, the dispense money will be given to the money dispenser. Then the money dispenser will be giving the withdrawal amount to the actor. For that, the ATM controller have to need a receipt in order that he took the money. So the printer will be accessible to print the receipt that he took the amount. And here we have a return message that is dotted message, which will be represented with the dotted lines. And in the ATM controller, we can see the eject card and end transactions, where the actor need to eject card in order to get the transaction details, and in transaction he have to remove the card. So there are some problems here and we have to rectify that. Components alt and else statements. So here we have a get balance statement, and with the dotted lines return value we will be getting the balance sheet. In the all statement we have to get a balance greater than or equal to amount. That is, the amount that is debited should be able to check the amount before the debited amount, whether the user have the enough amount which need to be debited or not. And store the photo of check, which means that the transaction details should be stored in order to have a proper statements and the balance sheet. This is the alternate. Or else, in the else statement, it is to add insufficient fund fee. If there is no balance amount in the user, then it have to show insufficient fund fee, and then the printed note should be given back to the user, and the return check. When coming to the user, the transaction will be ending over here. So the components options: register, register office, and accounts receivable, and drama class. Here we can see the another example for the components, that is option, as an example of the sequence diagram. Components loop. When we have conditions that need to be performed again and again and again, we will be using a loop statement, that is one of the components in the sequence diagram, to represent that there is a statements that need to be occurred again and again and again. Rules of the thumb. Rarely use options loop alt else. These constructs complicate a diagram and make them hard to read or interpret. Frequently, it is better to create multiple simple diagrams. Create sequence diagrams for use cases when it helps clarify and visualize a complex flow. Remember, the goal of UML is to communication and understanding. Summary. Sequence diagrams model object interactions with an emphasis on time ordering. Method call lines must be horizontal, vertical height matters. Lower equals later labels the lines, lifeline, dotted vertical line, execution bar. Bar around lifeline when code is running. Arrow, synchronous call, triangle, arrowhead. Asynchronous call, not waiting for a return, open arrowhead. And return call, dashed line. Thank you.